Okay, for section 8.1, we're going to look at the inverse sine, cosine, and tangent functions, okay? And before we even dive into this idea of inverse trig functions, we really need to take a trip down memory lane and go back and talk about a few things from Math 171, okay? So the first thing we need to understand is functions, their inverses, and something called a one-to-one function, okay? So let's review. First of all, we have that the inverse of a function f of x is found by switching the x and y values in each of the ordered pairs on the graph of f. So if you have the graph of your initial function, if you were to switch the x and y ordered pairs and then plot those, you would get the graph of the inverse, okay? And then we say, well, then the graphs of f of x and f inverse of x end up just being reflections about the line y equals x, okay? So you could technically sort of graph the inverse of a function by reflecting it about the line y equals x. And just in case you forgot, this is the line y equals x, okay? Now, we have this extra condition or this extra thing that we have to worry about. So we already know what a function is, okay? So a function is a situation where each input value corresponds to only one output value. So just generally speaking, a function, we have a situation where each input corresponds to only one output. And so essentially what that meant in like the most basic of terms is that x's can't repeat. And the way we would test this in algebra is, I can't spell, first of all, but the way we would test this in algebra is we would use something called the vertical line test. So in the vertical line test, you could draw or just kind of imagine sweeping a vertical line across your graph. If that vertical line were to intersect your graph more than once at any point, you would have a situation where x's repeat, you don't have a function, okay? So that was all well and good. But then we learned this idea of a one-to-one function. So a one-to-one function is a special type of function, okay? So in a one-to-one function, we have this special condition where each input corresponds to one unique output. So what in the world does that mean? Well, that means that now the y's can't repeat. So with a function, as long as your x's didn't repeat, it didn't matter what y was. Y could be anything, and they could repeat, okay? You could literally have unique x's and have them correspond to the exact same y value. That would be fine, okay? With a one-to-one function, however, the x's can't repeat, y's can't repeat either. So y's can't repeat either. And we had a little test for this called the horizontal line test. Okay, so the idea behind the horizontal line test is if you were to sweep an imaginary horizontal line up and down your graph, if you were to intersect the graph at more than one point anywhere, you would then have a situation where you don't have a one-to-one function, okay? And so understanding the idea of a one-to-one function is important because if f of x is a one-to-one function, it will have an inverse that is also a function. So that means when we take and we invert those x's and y's, we swap out the x's and y's, the resulting situation is also a function. So one-to-one functions will have an inverse that is also a function, okay? And so we have some weird notation down here. Don't get too hung up in it. Just try to like understand what's going on, okay? So you have to remember composite functions. So you talked a good bit about composite functions when you were in 171. And so when I would teach 171, I would always talk about stuffing one function into the other function. So imagine that. So that's as crass as you could possibly get when you're talking about functions. But if I have f inverse of f of x, that means I'm taking f of x and I'm stuffing it inside f inverse. So I'm basically evaluating f inverse for f. If I do that and I get it equal to x, then that means it's equal to x for every x in the domain of f of x. Okay? Now, if I do the reverse and I take the inverse and I stuff it into the function, so I get f of f inverse of x, that should equal x for every x in the domain of the inverse. Okay? So what does that ultimately mean? Okay? It's a lot of symbols, it's a lot of formal talk. But ultimately, what this tells us is that the domain of f of x is going to equal the range of f inverse, and the range of f is going to equal the domain of f inverse. So we basically, for a function and its inverse, we swap the domain and range around. So the domain of one is the range of the other. The range of one is the domain of the other. Okay? So that's like a really, really super, super, super fast, super quick review of a bunch of stuff that you did in 171. Okay? Now let's look at a very specific example here. So again, still 171. We have the function f of x equals the square root of x minus 1. So let's talk about that. First, off to the side, I am going to show you kind of what this looks like. So if I were to graph f of x equals the square root of x minus 1, that is essentially the graph of the square root of x shifted to the right one. Okay? So it looks kind of like that. Okay? So that's great. We can look at the domain and range of this. So we could say the domain of this, well, it would be from 1 to infinity. And we can say the range of this would be from 0 to infinity. So kind of tuck that off to the side and keep it in mind. Okay? Now, the first thing we're asked to do is find the inverse of f. Okay? So we're told to find f inverse of x. So what we do first is we replace f of x with just a y. So I'm going to rewrite this as y equals the square root of x minus 1. And then we already know that to find an inverse, you basically just swap your x's and your y's. So let's quite literally swap our x's and our y's. So I get x equals the square root of y minus 1. And then I want to solve for y. So in order to get the y alone, the first thing I need to address is this radical, this square root. So the way we would undo a square root is we would square it. So square both sides of this. So that gives me x squared equals y minus 1 because the square root and the exponent of 2, they just undo each other. They're inverse operations. Okay? And then in order to solve for y, the last thing I need to deal with is this 1. To get the y alone, I need to undo that subtraction, so I add 1 to both sides. So that tells me that I get y equals x squared plus 1. And once you swap your x's and y's and then solve for y's, you can replace y with f inverse of x. So let's think about that. Okay? Now, the next thing we have to talk about is the domain and range of f of x and f inverse of x. Okay? So I already kind of addressed the domain and range of f of x. Okay? So we have the graph of f of x right here. Okay? So we mentioned earlier that if you're dealing with a function and its inverse, they're basically just reflections about the line y equals x. So let's say this is the line y equals x. Well, if I were to reflect this, I basically just take each ordered pair and I swap my x's and my y's. So that tells me I would get a graph that looked like this. Well, that certainly doesn't look like a parabola, but this down here is definitely the graph of a parabola. So what do we do with that? Okay. Well, we basically have to say this is our inverse, but there's a condition on it. And the condition on it is it's only good from 0 to infinity on the x-axis. Okay. So I have to come back down here and say, hey, look, there's this condition, like this is all well and good. The inverse function is x squared plus 1, but only if I'm looking from basically here to here. So as long as my x values are 0 or greater, then we're good. So I would put the little condition here that this is the inverse as long as x is greater than or equal to 0. Okay? So keep that in mind too. Sometimes you have to play around a little bit with things. Now let's go ahead and state the domain and range. So if I want the domain of f of x, well, we already have the picture of it here. We just have that our domain was from 1 to infinity. And then the range of f of x, well, we have the graph here. So this was our original graph. So our domain is from here to here. Our range is from, and that goes forever. Let me put an arrow here. And then our range is basically from here to forever. So our range is 0 to infinity. Okay? Now we know also that with inverse functions, you can basically just swap your domain and range. So if I was looking at the domain of f inverse of x, well, it would be the range of f. So it's going to be 0 to infinity. And that kind of makes sense. We address that over here. As long as x is greater than or equal to 0, we're good. And then the range of f inverse of x is the domain of f of x. So it's going to be 1 to infinity. So you can kind of see that here to forever, and then here to forever. Okay, so hopefully that was an easy trip down memory lane. These are things that you should know from Math 171. Make sure you have reviewed the idea of what is a function, what is a one-to-one function. If a function is one-to-one, what does that mean about it having an inverse or not? What is the domain and range of a function compared to the inverse? And then how do you actually find the inverse of a function? And I've done an example here, okay? So make sure you kind of review all of these details because they're all very important in their own way when we start talking about the inverse trig functions.